Hello everyone, my name is Arthur Gupta and today I'm going to explain Compton Effect. Compton Effect is a topic of engineering physics. This is given as an assignment, so there is a time limit, but I will try to explain Compton Effect as much as I can and as much as clear I can. So let us start. First of all, before dwelling deeper into the Compton Effect, we should know what is Compton Effect. The scattering of a photon by an electron is called as Compton effect. We can also visualize it as collision between an electron and a photon as if both were billiard balls. As shown in the figure, an X-ray photon strikes electron and then gets deviated from its original position and by even losing energy. The loss of energy helps in gaining the kinetic energy or giving the impulse to the electron so that it starts moving in the other direction. Here we can say that the photon losing an amount of energy in the collision is the same as the kinetic energy gained by electron. So let us assume that the initial frequency of the photon is nu and the final energy after scattering of photon is nu dash. So by using the law of conservation of energy, loss in photon energy equals gain in electron energy. Hence, h nu minus h nu dash equals kinetic energy. From the previous chapter, we recall that the momentum of the massless particle is related to its energy by the form E is equal to Pc. Here we saw the energy of photon is h nu, and hence its momentum will be P equals E by C, which is P equals h nu by C. Here, unlike energy, momentum is a vector quantity that incorporates direction as well as magnitude. And in collision, momentum must be conserved in each of the two usually perpendicular directions. Here I have taken a picture where the momentum has been resolved along vertical, vertical, and the horizontal plane. Here the direction we choose are that of original photon and one perpendicular to it in the plane containing the electron and the scattered photon. The initial photon momentum is h nu by c and the scattered photon momentum is h nu dash by c, and the initial and the final electron momentum are respectively 0 and p because initially we have assumed that the electron is at rest. So by applying the conservation of momentum along the direction of the original photon, we get h nu by c plus 0 equals h nu dash by c cos phi because of the resolution in horizontal plane, and for electron we get p cos theta, same because of resolution in horizontal plane along the direction of the original photon. And in perpendicular direction, again applying the law of conservation of momentum where initial momentum equals final momentum. Here initial momentum will be 0 because we assumed that there is no motion of photon in the vertical plane, and the electron is at rest, hence there is no motion in the vertical plane. So the initial momentum becomes 0 and the final momentum for the photon becomes h nu dash by c sine phi because the component had been resolved now in the vertical direction. So in vertical direction, one direction we have to take positive and the other we should take negative because these are the vectors. So let us take this direction as positive and this direction as negative. If you want to note it down, you can note it down. Hence, initial momentum equals final momentum, and h nu dash by c sine phi minus p sine theta equals 0. The angle phi is that between the direction of the initial and the scattered photon uh, as shown in the diagram on the first slide, and the theta is that between the direction of the initial photon and recoil photon. Hence from these equation we can find the formula that relates the wavelength difference between initial and the scattered photon with angle phi between their direction, both of which are measurable quantities. The first step, hence we can rearrange these equations to form these equations. After rearranging, we can square each of these equations, both of the equations, and by adding them, the angle theta is eliminated because sine square theta plus cos plus wait, guys, sine square theta plus cos square theta equals 1. Here we can use a plus b whole square and here as simple square. So these equations will become, after combining, like this. This is the a plus b whole square, a minus b or a plus b whole square component, and the other component has been added. Next, we equate these two expressions for total energy of particle. The total energy will be kinetic energy plus mc square. So by rearranging it, we get E is equal to under root of m square c to the power 4 plus p square c square. From the previous chapters, we know that kinetic energy plus mc square whole square gives this, or we can find it from here only. And here from here we can find the value of p square c square. This value is quite important. This value is quite important. From the previous slides, we came to know that kinetic energy is equal to h nu minus h nu dash. Hence, by putting the value of h nu square, kinetic energy here, we get this equation. So as we got this equation, uh, we can substitute we can substitute the value of p square c square in this equation. So let me explain it. So we can put the value of this p square c square here. After putting the value, we get this equation. Now to just clear it out, and to explain everything in the wavelength term, we will divide the this equation we will divide this equation by 2h square c square. By dividing this equation with 2h square c square, we get mc by h into v nu divided by c minus nu dash divided by c equals nu by c, nu dash by c into 1 minus cos phi. So we also know that c by lambda equal to nu. Now by rearranging, we get c by nu equals lambda. Now putting the value of this equation in this, we get mc by h into 1 by lambda dash equals nu dash by c into 1 minus cos phi. And hence the final equation becomes lambda dash minus lambda equals to h divided by mc into 1 minus cos phi. This equation was derived by Arthur H. Compton in early 1920s, and the phenomena it describes, which he was first to observe, is known as Compton effect. it constitutes very strong evidence in the support of quantum theory of radiation. Uh, this equation gives the change in wavelength expected for a photon that is scattered through the angle phi by a particle of rest mass m. This change is independent of wavelength lambda of incident photon. The quantity is lambda c equals h upon mc, which is called as Compton wavelength for scattering particles. For an electron, lambda c is 2.426 picometers. And hence the final equation becomes, I am writing the final equation here, lambda dash minus lambda equals lambda c into 1 minus cos phi. Hence we get this equation. Now we can also explain the Compton effect uh, by the experiment. So the experimental demonstration of the Compton effect is straightforward. As in the figure explained, a beam of X-ray of a single known wavelength is directed at the target, and the wavelengths of the scattered X-rays are determined at various angles phi. The results shown in the figure 2.24 exhibit the wavelength shift predicted by the equation, which are given as these. These are the wavelength shift predicted by it. Uh, but at each angle, the scattered X-ray also include many that have initial wavelengths. This is not hard to understand. Like here, it has initial wavelength. Here, it also has initial wavelength. Here, it has initial wavelength. Here, it is initial wavelength. So this is not difficult to understand. When we were deriving the equation, when we were deriving this equation, when we were deriving this equation, I said that the scattering particle is able to move freely, which is reasonable since many of electrons in the matter are only loosely bound to their parent atoms. Other electrons, however, are very tightly bound, and when struck by a photon, the entire atom recoils instead of the single electron. In this event, the value of m to be used in equation is that of an entire atom, which is tens of thousands of times greater than that of an electron, as the resulting Compton shift is accordingly so small as to be undetectable. So this was the Compton effect, and I have also taken a numerical problem here, which is this: X-rays of wavelength 10 picometer are scattered from the target. Find the wavelength of X-rays scattered through 45 degrees. So let us do this question first. So this is the equation we just derived, where lambda c is equal to h upon mc. So here we just have to rearrange the equation by putting this here. So it becomes plus lambda dash equals to lambda plus lambda c into 1 minus cos 45 degree. So it is given that the initial wavelength is 10 picometers. So we put the value here 10 picometers. Angle to be scattered is 45 degree. Hence we use here cos 45 degree. By solving, we get 0.293 into lambda c. So we know that value of lambda c equals 2.426 picometers. So by putting the value of these equation, we get 10.7 picometers. And now taking the next question. The next question is find the minimum wavelength present in the find the maximum wavelength present in the scattered X-ray. So here it is given that lambda dash minus lambda is a maximum when 1 minus cos phi equals 2, in which case so you might be confused that why 1 minus cos phi equals 2. So the minimum value of cos phi or minimum value of cos is minus 1. Cos is from minus 1 to 1. Minimum value of cos is minus 1. By putting here minus 1, we get equals 2. Lambda dash minus lambda is maximum because it is related on this factor only, because lambda c is constant. Hence, putting various values here, we get 14.9 picometers. And the next question, the last question, is find the maximum kinetic energy of the recoil electron. So the maximum recoil energy is equal to the difference between the energy of incident and the scattered protons. So photons, not protons, it's photons. So kinetic energy max equals to h nu minus h nu dash. This came from the first equation uh, where we equated the energy of photon and energy of gain in electron energy. From here, it from where when we take h common, it becomes nu minus nu dash. So uh, we know again that c by nu equals lambda. Putting the value here, taking c common, we get hc into 1 divided by lambda minus 1 divided by lambda dash. Lambda dash is taken from b, which is 14.9 picometers. We have value of h, we have value of c. Put the value and we will get the answer, which is 40.8 kilo electron volt, 6.54 into 10 power minus 15 joules. So this was my lecture on or explanation on the Compton effects.